Yes. So first of all, let's read the question again. Question number 3. An investigation was carried out into the changes in concentration of antibody molecules in the blood of 2 people. So the concentration of antibody molecules in the blood of 2 people, they were investigated. Here in the following graph, you can see that person R was given passive immunity, whereas person S was given active immunity. So passive immunity means the person R was vaccinated and the vaccine contained antibodies. And person S was given active immunity. That means the person S was also vaccinated, but the vaccine contains pathogens, attenuated cultures of pathogens or dead cells of the pathogens. Okay. Now the concentration of antibody molecules in their blood is shown in the following graph. So as the person R, you can see here in this graph, I'm just zooming in this part. So here you can see in this graph that as person R was given passive vaccines, or person R was immunized with passive immunity, so the vaccine contained antibody. Person R has got ready-made antibodies. They have at the moment they are introduced in the body of person R, they have started working immediately. So this is why the concentration of antibodies you can see in person R, they increased instantly. You can see here the rays. So instantly they were increased because antibodies are inserted in the body. Whereas person S is not injected with the antibodies. Person S has given the vaccine and the vaccine contained attenuated cultures of the or inactivated cultures of pathogen or dead cells of the pathogens. So the person S will first recognize the pathogen, then they will activate the cells, lymphocyte cells will be activated, then they will the clones will be made. After that they will deactivate they will start deactivating the antigens. So for that, primarily for that activation, detection of antigens and activation process, the person is the making of antibody in the body of person is, it will take time. This is the time that person is taking, but the person R is not taking. But here you can see what you have just said, that person R, as he is given the passive immunity, so it has got the antibody molecules in some particular amount. So it is not a long term or long time immunity, and it will right? Not make any the antibody molecules that are given, only they will act on the pathogens, and after the pathogens will be removed, the antibody molecules will also undergo the apoptosis process. That means they will be destroyed. This is why at the 90th day, the number of antibody becomes 0. But as person S has got the active immunity, so though it takes time to make the antibodies, but once the antibodies are made in the body of person S, they stay in the body for a long period of time, and they also make the memory cells. So it will never become 0, right?
That's why active immunity is said the long-term process.
Long-term process or long-term immunity. Whereas passive immunity is a temporary. Though it gives the immunity instantly. If we don't have time, if our body is too weak
or enough of pathogens enter our body and breed there.
So many pathogens have entered our body. So we need that passive immunity in that case, because we need to act instantly. Okay, so this is why. So start writing the answer. I'm telling it.
Yes, ma'am.
Right.
Question number 2, ma'am.
3, not 2.
Question not. Write the answer.
Oh, ma'am, I'm doing 3.
Right. The concentration of antibody molecules. The concentration of antibody molecules.
So this is question number 2.
No, question number
3A2.
Question number 3. Question number 3A2. Question number 3A2. Okay.
Concentration of antibodies molecule.
The concentration of antibody molecules shown in the given graph
Shown in the given graph decreases.
decrease to 0 in person R.
Shown in the
Decrease
given
to
R.
0 R. Yes.
In person R.
Yes. Decrease to 0 in person R.
Ma'am, can you tell shown the
Okay, I'm telling
given?
it from the very first. Okay, first line. The concentration of antibody molecules shown in the graph or shown in the given graph decreased to 0 in person R by day 90.
By day 90.
Because by day 90, because person R was given passive immunity. Because person R was given passive immunity.
Passive immunity.
Which is a temporary mode of immunity. Or don't write temporary mode, which is not a long-term immunity. Because person R was given passive immunity, which is not a long-term immunity.
No.
Immunity. After that, passive immunity.
Which is not a long-term immunity. And after all the pathogens are removed from the body,
Pathogens.
It's not a long-term immunity after that.
Yes, and after all the pathogens are removed from the body, the antibodies also undergo apoptosis process. The antibodies
after all
also
the pathogen removed.
After all the pathogens are removed from the body, the antibodies also undergo apoptosis process.
Yes, ma'am, done.
The antibodies.
And finally, the antibodies also undergo apoptosis process.
And finally,
the number of antibodies become 0. And finally, the number of antibodies become 0. As no memory cells. And finally, the number of antibodies become 0 as no memory cells are produced. And finally, the number of antibodies become 0. The number of antibodies become 0.
Become 0.
And no memory cells are produced.
Yes,
and no memory cells are produced in passive immunity. And no memory cells are produced in passive immunity. Okay, now you repeat the answer that I have told you. Who has completed writing?
Yes, ma'am, I am telling. Yes,
okay,
ma'am. The concentration of antibody molecules shown in the graph decreases to 0 in person R by 90 days because the person R was given passive immunity, which is not a long-term immunity. And after all the pathogens are removed from the body, the antibody also goes to apoptosis process, and finally the number of antibodies becomes 0 as no memory cell are produced in passive immunity.
Very good. Okay, so other students have also written the same answer.
Yes,
now let's see what is the next question.
Yes, ma'am.
Yes, ma'am.
Question number 3. explain why the concentration of antibody molecules shown in the graph for person S did not start to increase until 10 days after the injection. So you already know the answer. Any one of you tell me? I have told
Yes,
the
ma'am,
answer.
because
Ma'am, because it will
the
lim
antibody which is given to the third person, that helps them to helps that body cells to make antibody on that person, and
So it will
that's why
take the time. It will take the time of 10 days
The
for the
lymphocyte
detection
will
of
take the
antibody
time
molecules
to know
and
that
for
antigen.
making the
and
antibodies, particular antibodies for particular antigen
yes,
molecules.
ma'am.
At the same time, for the activation of lymphocyte cells, it will take some time, and the duration is 10 days, right? So
Yes,
start
ma'am.
writing
Yes.
the answer. Write it. Write the concentration of antibody molecules shown in the graph. The concentration of antibody molecules shown in the graph for person S
of
start to increase, did not start
concentration
to
of
increase.
antibody molecule.
Antibody molecules.
Concentration of antibody molecules shown in the graph for person S did not start to increase until 10 days after the injection. The concentration of
Person is
antibody molecules, here I'm just marking it right exactly as it is written in the question. Same line.
Did not start to increase.
The concentration of antibody molecules shown in the graph for person S did not start to increase, until 10 days after injection. Until 10 days after injection.
After injection.
Because once a new pathogen enters, because once a new pathogen enters any body,
once
or
a new
right, once
enters
the
the person's body.
yes, enters the person of any enters the body of any person, it takes
because
some time.
once
Once a pathogen,
And the person of
once
anybody.
a pathogen
enters the body of any person.
no, it's not the person of anybody, the body of any person.
can
Okay.
anyone stop? Please tell me, ma'am. Ma'am, can you tell again? I can't hear.
The concentration of antibody molecules shown in the graph for person S did not start to increase until 10 days after in the injection, because once a pathogen enters the body of any person, it takes time for the detection of the pathogen. It takes time for the detection of the pathogen.
Enter the body of a person.
Of a person, it takes time, or then it takes some time for the detection of the pathogen.
The pathogen. Yes, ma'am.
Activation of, for the detection of the pathogen, activation of lymphocyte cells, activation of lymphocyte cells,
Detection of the pathogen and the
for the detection of the pathogen, then put a comma, activation of lymphocyte cells, activation of lymphocyte cells, and production of particular antibody molecules for particular, for that
lymphocyte cell.
particular antigen. Detection of antigens or detection of the pathogen, activation of lymphocyte cells, and production of antibody, particular antibody molecules for that particular kind of antigen, and production of particular antibody molecules for that particular type of antigen. For person S, that time period is 10 days. For person S, that time period is 10 days.
For person is
For person S, that time period is 10 days. Is it clear?
yes.
So what time period? The time period that is needed for the activation, for the detection of pathogen, for activation of lymphocyte cells, and for the production of antibody molecules, which are
For that particular antigen.
type of antigen that has entered the body. So it takes some time. And for person is the time period or the duration is 10 days. Okay.
Yes, ma'am.
Now repeat the answer. Read it.
The concentration of the antibody molecule shown in the graph for the person age did not start to increase until 10 days after the injection, because once a new pathogen entered the body of that person, it takes some time to detect the pathogen, activation of lymphocyte cell, and production of antibody molecules for that particular type of antigen. For person is that time period is 10 days.
Okay. Is it clear? If there is
Yes,
any
ma'am.
doubt
No,
regarding
ma'am.
this answer, you
No,
can
ma'am.
tell
No,
me.
ma'am. No, ma'am. No, ma'am.
Okay. So now let's see what is the next
And we
question.
can add one line here that
Yes,
it also make memory cells.
yes, memory cells they will make at the last. Okay, here the question is the concentration of antibody molecule increases or it do not start increasing until 10 days. Why it takes that 10 days time? Because in person R you can see instantly at the very first day it is raising. But in case of person S, why it is taking 10 days time to increase the antibody concentration? The memory cell, making of the memory cell or production of memory cell, that is the last stage of immune response. Remember the 5 stages of immune response. First
Ma'am,
one
yes.
is detection. Second one is
Yes.
activation. Third one is clonal expansion. That means they will
Clonal
make more
expansion, yes.
Copy,
antibodies.
copy.
Yes, and the
Yes, for
fourth
copy.
stage is
Apoptosis.
No, antigen.
apoptosis. So when they will make the antibody, so the antibodies start working with the antigens, they will deactivate
Antigens,
it.
yes, ma'am.
Fourth stage is
Ma'am.
apoptosis. That means
And the
finally
fifth
when
stage
all
is
the
memory
pathogens
cell.
will be removed by the antibodies, the cells will undergo apoptosis or die or they will be destroyed. And the last stage is memory cells. Okay, so memory production of memory cells. The
If we
cell, the
add memory cell, then we have to add apoptosis process also.
yes. So the lymphocytes that will survive the apoptosis process, they will be stored in memory cells. They all the antibodies that are particular to the antigen. Okay, so memory production is it's a very important point, but this is the last stage of immune response. Okay. So now
Okay,
let's see what is question number B. Breast milk contains antibodies which are absorbed by the baby. The antibodies give the baby immunity to the diseases to which the mother is immune. State the type of immunity that the baby has as a result of absorbing the mother's antibodies. Okay, and it contains
2 marks.
2 marks. Passive immunity.
Okay. So here you will
Yes, ma'am, passive immunity
passive immunity.
because babies are taking
You have
antibodies
to
from
Yes.
their mother.
Yes.
Passive immunity. It is
yes,
already
yes,
given in
Bhavya.
Antibody from a mother in the breast milk across.
because the newborn baby they cannot make their own antibodies.
Yes.
They cannot make their own antibody. This is why they are getting the antibody directly from the mother, from their mother
Mother.
through
Through the breast
mother
milk.
through the milk. So this is why this type of antibody will be called
Passive
a
immunity.
Passive immunity.
What happened? Ma'am, what you are telling, I cannot listen.
Yes, ma'am, we can't hear you.
अरे क्या बोलছে কি
Oh.
বলছে ম্যাম can't hear ma'am you
Oh,
Can you hear me now?
yes, ma'am.
yeah
Yes, ma'am.
Yes.
Ma'am has
The
joined from
device
today.
from which I was sharing the screen, it got disconnected. Now you start writing the answer. Write it. Write what is exactly written in the question. Write that first. Okay. Breast milk contains antibodies which are absorbed by the baby. The antibodies give the baby immunity to diseases to which the mother is immune. To which the mother is immune. Right up to this, exactly as it is written in the in your book. Write these two lines exactly as it is. Then I will tell you the answer. What to write. Okay?
yes
So I'm
ma'am.
also showing that part on the screen. You can see it here also. Breast milk contains antibodies which are absorbed by the baby. The antibodies give the baby immunity to the diseases to which the mother is immune.
which are absorbed by the baby the antibody gives
I'm again telling the sentence. Breast milk contains antibodies which are absorbed by the baby. The antibodies give the baby immunity to the diseases to which the mother is immune.
Yes, ma'am.
Okay.
Done.
no wait ma'am
Now
Oh,
write
ma'am, wait.
as a result,
Ma'am, wait.
As a
result
result.
of absorbing the mother's antibodies, as a
Ma'am,
result as a result of absorbing the mother's antibodies. See, it is also written in the question. As a result of absorbing the mother's antibodies,
Antibodies.
the baby
wait ma'am as a result
Baby.
of
absorbing the mother's antibodies, the baby
the
gets
mother
passive
antibody.
immunity. The baby gets passive immunity.
The mother
Antibodies, the baby
After that?
gets passive immunity.
Immunity.
baby get passive immunity.
Passive immunity. As the baby cannot make the antibodies,
As the baby
As
cannot
as the babies cannot make antibodies,
make
newborn babies, okay, add this newborn word. As the newborn babies cannot make antibodies themselves.
antibodies cell
As the
Ma'am,
newborn
cannot make their
babies cannot make their and make the antibodies themselves.
themselves.
The antibodies cannot make the antibodies themselves. Have you written up to this?
Yes, ma'am.
yes, ma'am.
The antibodies, sorry, right, their mother's antibodies are okay, right, the antibodies they're absorbing from the mother.
Antibodies
The antibodies they're absorbing from their mother protects them from many diseases. Protects them from many diseases. If the question carries, here the question carries 2 marks or 3 marks, this is why you will have to write this much. If the question carries 1 mark, then what you will write? You will simply write that the baby has a passive immunity as a result of
protect
absorbing
them
the
from the
mother's
pathogen.
yes,
Protect them from the
from
pathogen.
the diseases.
from various diseases. Okay,
From
from
various
various
diseases.
diseases.
Okay, ma'am.
See, again, I'm telling you, if the question carries 1 mark, then no need to write all these sentences. You will write only one sentence And what
Yes,
is
ma'am, we
that?
can
You will
write.
just write that the baby has a passive immunity as a result of absorbing the mother's antibodies. That's it. You
Yes,
don't
ma'am.
need to write anything else. But if the
Okay.
same question carries 2 marks or 3 marks, then only you will have to write this answer. Okay.
Okay,
So
ma'am.
Okay,
you
ma'am.
that the answers that I'm just telling you, these are a little bit large, right? You will have to write 2 or 3 sentences. Why?
Yes.
Because 1 mark, if the question carries 1 mark, if you read these answers, you yourself, you can make it short, right? You can
Yes, ma'am.
write only one single sentence. But if the question carries 2 or 3 marks, then what you will have to write, how you will have to explain it, this is what I'm telling you. So the same answer you will write in one sentence, that the baby has a passive immunity as a result of absorbing the mother's antibodies, if the question carries 1 mark. But always look at the marks that the question carries. If it's of 2 or 3 marks, then you will have to explain a little bit. Okay.
Yes.
So let's see what's the time. Okay,
We have time, ma'am.
Write the
We
next
have
question.
time.
Yes. So write question number 4. These questions are about the graph in figure 10.16 on page 136. Okay, so let's go to page 136, figure 10.16 first. Let's see,
Yes,
then we
ma'am.
will come back to the
Wow,
questions.
that is
We are
wow.
telling about vaccination.
Yes.
This one about vaccination. In
Explain. Yes.
1944,
Yes,
I
ma'am.
have
You
told you
already
about this one. Just
Yes.
let us remember this one. So the x-axis indicates the year, and the y-axis, what we have plotted the cases in thousands. Cases of what? Cases of